Today we're on page 1 of our second Chapter 4 notes packet, Section 4.7, Composition of Functions. Now you applied composition of transformations in geometry. For example, if you had something like a rotation of 90 degrees, composition with a reflection in the x-axis to some point, we'll call it point having coordinates 1, 2. Recall from geometry which transformation was done first. Well, it was the one to the right. So the reflection was done first, and then to that result you applied your rotation. The same follows with functions. Right? For two functions such as f and g, the composite f of g means that the function f follows the function g. That is, the second function is applied to the result of the first function g. An alternate notation for f composition g of x is you can have the nested parentheses where you would do g of x first and then to that result f of that result. Both are said f of g of x. Example, if f of x equals x squared and g of x equals x plus 1, evaluate. All right, so we have f of g of 3. Draw the box. G of 3 is done first. What is g of 3? Well, we go to our g of x, replacing our x's with 3. So g of 3 equals 3 plus 1. And 3 plus 1 is 4. Now we want f of 4. So go up to f of x, replacing our x values with 4. So f of 4 equals 4 squared, which is 16. So our answer is 16, and only 16. You don't give an answer of 4 and 16. Our answer is the end result. Number 2, g of f of negative 2. We want f of negative 2 first. Looking at f of x, replacing our x's with negative 2. So we have negative 2 squared. Negative 2 squared is 4. Now g of 4. G of 4, going to g of x, replacing our x's with 4. So that's 4 plus 1. So g of 4 is equal to 5. Now, finding rules. This is where you're not evaluating a number, but rather you're evaluating a variable. So in other words, we have g of x. Well, what does g of x equal? It is our x plus 1. Okay. Now we want f of x plus 1. So we replace our x with x plus 1. Do the same back to the original function. Replacing this x with x plus 1, we also replace this x with x plus 1. So that would be x plus 1 squared. FOIL that, and you get the trinomial x squared plus 2x plus 1. So this is considered the rule of f of g of x, because the variable remains. We're not evaluating with an actual number. Next, g of f of x. Okay, do f of x first. What does f of x equal? It equals x squared. Now we want g of x squared. So I'm going up to g of x, replacing our x's with x squared. So this also gets replaced with x squared. So that's x squared plus 1. Can't do anything with that, so that's our answer. Example 2. If f of x equals x squared plus x and g of x equals x minus 3, evaluate. All right, well, first we have f of g of 5. G of 5 is done first. Make sure you're looking at the correct function. So we're replacing x in g of x with 5s. So that's 5 minus 3, which is 2. And now f of 2. Go into f of x, replacing our x's with 2. So that would be 2 squared plus 2. That's 4 plus 2 is 6. So our answer is 6. Next, g of f of negative 4. F of negative 4 is done first. Replacing our x's with negative 4. So this is negative 4. Make sure you put that in parentheses. Squared plus negative 4. Negative 4 squared is positive 16. Plus negative 4 is 12. Now g of that result. So g of 12. Looking at g of x, replacing our x's with 12. So 12 minus 3, which is 9. Find the rules. F of g of x. Okay, g of x, well, that's just equal to x minus 3. Now f of that, so f of x minus 3. We're looking at f of x, replacing our x's with x minus 3. So x minus 3 squared plus x minus 3. Well, x minus 3 squared, remember the FOIL, all right, x minus 3 times x minus 3 is going to be the trinomial x squared. A minus 3x and minus 3x is minus 6x. Negative 3 times negative 3 is positive 9. We have the plus sign in front of that parentheses, so we can just drop the parentheses and bring down our plus x minus 3. And now combining like terms, we have x squared minus 5x plus 6. And number 8, g of f of x. Again, evaluate f of x first. Well, f of x is simply x squared plus x. Now we want g of that. So g of x squared plus x, we're looking at g of x and replacing all our x's with x squared plus x. So x squared plus x. And then don't forget, bring down the minus 3. Nothing can be done there. That's your answer. If we look at our results here of f of g of x and g of f of x, right, they are not equal. So the composition is not what we call a commutative operation. Next, page 2. Composition of functions graphically. When finding f of g of x or f of g of x graphically, find the value of the right or inner function. Then, using that result, find the value of the left or outer function. So we have here in example 1, given the following graphs of f of x and g of x, evaluate the following compositions. Okay, you need to be able to try to see both of these graphs. For number 1, we want to evaluate f of g of 3. Well, key here is make sure you are looking at the correct function. Make sure you are looking at the correct graph. F of g of 3. We want g of 3 first. So we go to our g of x graph. G of 3, find our x value of 3. Where are we at the graph? Here we are at 3, 1. What's the y value? 1. So g of 3 equals 1. Now, f of that result. What is f of 1? Make sure you're looking at the f of x graph. F of 1, y value is 5. That's it. Number 2, g of f of negative 2. Finding f of negative 2 first, so make sure you're looking at the f of x graph. F of negative 2x value on the graph puts us at, looks like a negative 4y value. Now g of negative 4. Go to the g of x graph. G of negative 4, let's see, negative 4, point here, y value of 4. Number 3, f of g of negative 4, okay? G of negative 4 first. Negative 4, y value of 4. Now f of that, f of 4. F of 4 on the graph, here we are at negative 4. G of f of 1. F of 1 is evaluated first. Make sure you're looking at the f of x graph. F of 1, we're up here. At this point, y value 5. Then g of 5. G of 5, here we are. Y value 3. Next, number 5, we have g of 6. Okay, well, g of 6, what is that? G of 6 is 4. Now we stay with our g of x graph, and now we evaluate g of 4. All right, g of 4 is 2. Simple. Example 2. You can probably try these on your own if you want. Pause the video and try them. Okay, given the following graphs of f of x and g of x, evaluate the following compositions. F of g of 2. Let's see if I can get both graphs here. All right, we want g of 2 first. And do you have to write this out each time? No. You can simply look, oh, g of 2 is 3, and then I need f of 3. F of 3 is 5. So you can go right to the answer if you like. You don't have to write it out each time. 7, g of f of negative 2. So we do f of negative 2. Evaluate f of negative 2 is 2. And then g of 2. G of 2 is 3. F of g of negative 8. So we want g of negative 8. G of negative 8. Where's negative 8? Here we are. Y value is negative 2. And now f of negative 2. 2. G of f of negative 6. F of negative 6. Negative 4. G of negative 4. 0. F of 3. So f of 3, all right, let's go back here. F of 3 is 5, and then I'll stay there. And then f of 5 is going to be 6. All right. And I'll stop there. Ask you to do the last 4. And we'll go over that tomorrow at the beginning of class. Thank you.